It's Rustin here, coming at you with another update regarding the digital twin slash inside out project. So we actually flew today. I'm just going to zoom out here real quick. I'm in the middle of aligning some GCPs. I just wanted to take you guys along. But yep, we flew today. We flew one at about 140 feet AGL. That's what this top one is. There's some residuals here. I'm not too worried about that. That's what I'm correcting right now. And then I flew at 100 feet with a negative 55. And I did an east-west and north-south pattern. So we got a lot of data here, which is very good. Thank you to Dr. Daniel Harris, I had some control points surveyed and I just reprojected them in Pro and I put them in here. And that's what I'm currently tweaking right now. You can kind of see this is ground control point 3 right there. I did 1, 2, and 3. I still have 4 and 5 to do. So I just wanted to take you guys along here while I do that. So we're gonna go back to this view. Let me scoot over. I'm going back to how I had it. It was much easier this way. So you can see, I'll just show you. For example, these perspectives, this is the control point. It's a nice little marker. These ones are all locked in. You can see these are all locked, right? There's no uncertainty in any of these. These other ones, I have no no parameter or pictures that it's referencing set currently. So that's what I'm taking on to do. So I'm going to click on this fourth GCP, which I know is about here in space, but it's the reason why it's projected underneath. I think you saw that, might have saw that earlier. The points are actually underneath the projection. Is because we were using two separate coordinate systems, but no worries. It's not going to be perfectly 100%. That's why we're anchoring. That's the whole point of these points, is to sit there and make everything nice and tied together. So let's go through that. So number 4 here, I'm going to push F3, and that's going to activate my referencing. So you can see it's now pulling it from all the different images. So I'm going to go to where 4 should be. Now, if I zoom in, I should be able to see it. I think it was right by this manhole cover. If I did it right, somewhere around here. There it is. There it is. I see it. So here's my point. Let me zoom back out. Let me deactivate this and scoot over. It's okay. This is the RTK is more accurate because this was flown with GPS, and that's what I'm doing right now is PPK, post-processing kinematics. So we're trying to correct for that. Um, so yeah, there you go. You see it. There's the marker. So let me plot that point right there. We don't have to be 100% on the dot with that, and I'm going to deactivate it F3 again. We don't have to be 100% on the dot for that, but because we're going to sit here and confirm all these. Now, these are image suggestions. These are just going to suggest, like, oh, in space where that point is. Now, that obviously is not the point and isn't really a good reference picture, so we're going to actually remove that one. I want a nice, cleaner one. That's not referencing it, right? So you come here, you take this point, you zoom out, you plop it where it should be. So I kind of go for like 5 of these. It usually works pretty well. This is the error in terms of pixels, by the way. So it's kind of cool. This is like, look, if you look at the pixel, what the error is here. I don't know why you're being uncertain. I don't like that. So we're gonna have to kind of re-anchor these. It's okay because we're gonna reproject this anyway, and it will be corrected in that sort. So I'm not too super duper worried about all this. But why is this one's like super low res? I don't know. Maybe some file issues. That's okay. That's what we're learning for. So yeah, here. This one thinks it did pretty good. So let me refix him. Hit the corner. Good. We come here. That has nothing to do with that. Again, remember, these are just image suggestions. It's just in the area. It's pulling from the map that we had. It's not gonna always, none of these are going to be perfect. That's why I'm coming in here and changing them. Some of them aren't even right, but you can see what I'm talking about, how it's like from this image, oh, that's the point. Like we know what point it is in space. So that's what I'm doing right now. If I can't move it because I have it locked. But you know what I'm talking about. It's referencing. I'll put it to here so you can kind of see what happens as I go through these pictures. But it's referencing that point. It's kind of awesome. Actually, it's a really cool piece of technology. I like this. This stuff is so awesome. But yeah, look, this one was already on the money. Check that out. So we got that one pretty good. This one's kind of got it too. Might confirm. I'll confirm this one, and then maybe one more. Let's do six, just because this one had a little bit of error predisposed in it. I want something that's a little bit different. Yeah, that's a good perspective. It's a great perspective. Just move it a tad, yeah. And I'm going to clear these image suggestions in the 2D. Compare. Boom. So look at that. We got a couple good anchors. These are our known anchors now. You can see this in this vector field. But yeah, let's come to five down here. Now there was a box truck. You can literally see it. I pray that you can see through a couple of these around the box truck. If not, it's going to suck a lot. So moment of truth. It's actually what I started recording for because I've never had to come around with that type of issue. So I pray that we can actually see the point that we're trying to plot or map. So yeah, see how it's in here in some of these pictures, but not in here in these ones. I was like, dude, is he like right on top of it? And oh, it's right there. I see it. Yeah, we lucked out. Yeah, we lucked out pretty darn good. I don't know why it's bouncing. Oh no, come on, cooperate with me. There we go. Let's get out of the point mode. These oranges are residuals, by the way, if you guys were wondering. So now let's go confirm a couple of these. That looks pretty good, but let's put it right on the money. That one's confirmed. I don't know why this raster is so low res. I think it's just because I'm recording and it's got all this data processing stuff going on right now. So Lord forbid I actually use my laptop. I'm using 100% of my GPU probably, or CPU. Uh, Doing great. Oh, that's a good one. This is a nice oblique perspective, so it knows it's separate from the box truck. That's actually probably very helpful. So let's see if it gets. I actually wonder when it goes to process this if it will ignore the box truck or not, because the box truck is in here. I know it does a good job ignoring people, but I don't know if it'll do a good job ignoring the box truck. So we can see. I mean, this one looks right. Yeah. And then we'll go back here, clear these extra suggestions. Yep. And let me save real quick too. All right, and I will be back once we start the next step. All right, so I just was looking at a couple things. We're going to actually export these ground control points out. And this is now in the term of the image pixel files, which is kind of cool. We can see here that the residuals are pretty high. I am going to fix them. Don't worry, it is mainly caused from the error in the vertical systems. Again, one is known and the other is unknown, so it's guessing it. So we're going to export it. And then, funnily enough, we're going to import it back in, just like that. Um, yeah, I'm fairly confident. Yeah, let's do that. It's okay. And then we're gonna come back here. It should suggest a couple more, if I remember. No, I might have to manually do it. That's all fine. Um, so hold up. Repeat this. Let's highlight these. I don't know why you did that. Suggest. So add a couple of these suggestions back. I have a couple of these already confirmed. Sounds good. All right. Save that. These errors are still pretty high. Hopefully we can fix them. I'm just gonna confirm. I think I'm just gonna confirm a couple more of these just so I feel a little bit more confident about when it reconstructs itself. Let me go up to like here. This DJI one. Yeah, you can still You can see that one there. Sweet. There we go. Yeah, I feel confident with these ones. Um, all right. So alignment. We can let me we gotta disable the fire post real quick. So I don't want it to break. Give me 2 zip seconds. All right. So I deselected all the control points and I selected all of the camera poses. I'm coming in here into our prior pose and I'm setting this to unknown now. Basically, I'm removing all the tethers and we're going to update it. Now, this should update based on all of the different ground control points that we've now anchored and hopefully realign and make our model more to scale and basically squish and morph it so that it fits within the constraints that we have. So we shall see what that does. All right, so now if we look here, we can see that our accuracy from our ground control points worked. This process for probably about 10, 15 seconds to recalibrate all these cameras so that they fit within the constraint of their control points. But we can see now they're pretty tethered, right? We don't really have too many crazy ghosting artifacts like that. I mean, obviously we have our little tie points that are kind of scattered about, but that is what it is. So from there, we're gonna realign our images here. I'm going to change a couple settings though, real quick before I do that. Actually, I already had it done, so that's actually kind of awesome. Yeah, that actually be plenty of fun. So, yep. All right, I'm gonna run this. I guarantee it's gonna take forever. It says 321. I highly doubt it's gonna be 321. Um, but yeah, we'll see how long this takes. I'll be back once this is done. I guess look here, and we'll see. Yeah. All right. Again, I told you more than 1 minute. So this is our newly generated model. Again, all our points look good. We have a couple of these resids. That's okay. Look at how much more accurate each of these are now that we fully regenerated. That was a great decision. This is our old one. So you can see our accuracy, our old model and our new model. So component 3 would be our model. What's our small components? I feel like we have just a couple ghosting. Yeah, we should have some ghosting artifacts. These are nothing crazy. I'm not too worried about these, so we can get these kapoo. I'm gonna keep model 3. I'll drop these two. I'll make model camera 3, sorry, component 3 our current one. So now this is our current model. Yay. We can sit here. This is still a dense point cloud. We have not actually made anything out of this yet. I'm thinking maybe tomorrow, or let me walk around with the 360 camera basically and trace this. I'll put it this way. I'll trace this outline here and walk around Henson and see what data I can get, see if I can cover these lower bottom gaps with that. Hopefully something from there happens. It might be kind of cool actually what we can do. But we'll see. But yeah, this is a pre-processed, well, I mean, it's processed and it is referenced, but a uh, modeled version of Henson, at least on the outscale or outside to scale. This is to scale. This is in the WGS 84 coordinate system, the global one. So yeah, kind of sick, right? This was all done with a Mini 4 Pro, a couple of different waypoints and flights. And again, these are all the different camera angles you can see. And again, these are just some residuals. Again, nothing too crazy. I mean, look how accurate most of these are. So I'm not even fretting about these like what, like 5, 6 poses. We can see that we disregarded a couple camera poses. That's okay. That's all good. That's more data, the better, for, you know, making sure we have everything covered. So yeah, that was a great decision. So yeah, thank you guys for coming. Just wanted to share with this. This is kind of cool stuff. Cool stuff we're doing. So yeah, take care, guys.